Well, hello, my little triglets. Welcome to Video Math. Today we're going to talk about 5.1, section 5.1 in your book. Now, if you ever can't get to one of my videos, for whatever reason, it's always a good thing to take notes out of the book. At least look it over before you get to class. And then you can watch the video later when it is not an issue. Section 5.1, it's a lot of new vocabulary for you, and we're going to be talking about angles, which you're familiar with, but we're going to talk about degrees and radians. Degrees and radians are maybe something you're not familiar with, so we're going to take this nice and slow. We're going to take a couple days to do this section. So the title of the section is just angles in degrees and radians. Now we'll talk about radians in a minute. First, let's talk about how we're going to draw these angles. We're going to do an XY chart here, or an XY grid, and our angles are always going to start here and go upward. It's like opening a book. This is angle theta. That's spelled T-H-E-T-A. It's a Greek letter. I don't know why they chose it, but they did. It's kind of a neat little symbol. And this side here that we start our angle is the initial side. And let's say my angle ends here. This is called the terminal side. Okay, so just to get the lingo down, initial and terminal. If it's going in this direction up, it's a positive angle. If the angle happens to go down, it's just going to be a negative angle. So, angles, you know that in a circle there's 360 degrees. And do you know, like on the clock, we have hours, minutes, seconds. Do you know that degrees have degrees, minutes, seconds? And it works a lot like the clock. For every 1 degree, that equals 60 minutes. And for every 1 minute, that equals 60 seconds. So if you see those guys out on the road surveying the property, they use angles to degrees, minutes, and seconds. They have to get it really, really fine-tuned. Now think about that. If I have 1 degree, now I'm not going to be able to really draw it. Think of there's 360 of these going around that circle. And this is a little too wide, but just to show it. Think of breaking that into 60 little pieces. Each of those is 1 minute. Now think of taking 1 minute and breaking it into 60 pieces, and that's 1 second. That's pretty small. And they need it that small. If you're building a skyscraper, you can't be very far off, otherwise your skyscraper is going to be tilting and might look like the Leaning Tower of Pisa or something. And we don't have those in the United States. All right, so to write it, I might say something like 31 degrees, 47 minutes, and 12 seconds. All right, that's how it looks. So the words are minutes and seconds, but the symbols look like feet and inches. So it's all kind of mixed together. Now, thinking about that problem right there, if I want to change or convert to decimals, let's say your calculator has to have it in decimals. Well, 31 degrees is fine. 47 out of 60 minutes. And then also we have 12 seconds. Come on. 12 seconds out of 360, or 60 times 60 was 3,600 600th of a degree, because it's 60 out of 60. So that'd be 3,600. So multiplying that out and adding the decimals together, I get 47. Nope, I need to go back a little bit here. All right, so I've got, adding all those up, I get 31.787. Now I rounded that, but that's how many degrees it would be if it were in a decimal. Now sometimes you have it in decimals and you need to get back to this point. So let's try one of those. In fact, let's just use the same one we just did. And if I have 31.787, now remember that's rounded, so we might not get exactly the same thing we had before. So the process is take that, because this is all a degree, and I know that that's my full amount of degrees. Now I have a decimal of a degree, so I am going to, instead of divide by 60, I'm going to multiply by 60 to get that, and I get 47.22. Now I know the 47 is my full amount of minutes. Then I'm going to take the 0.22 and multiply it by 60, not 3600, because together, since I already multiplied it once, if I multiply it a second time, that will be equivalent to 3600. So you're going to multiply by 0.22 by 60, and you get about 13.2. And that's, oops, that is the full amount. We're going to round to the full amount of minutes there. So 31 degrees, 47 minutes, and 13 seconds. Now that wasn't exactly what we had. The other one was 12 seconds, but remember, because we rounded, that might happen. All right, the next word I want to introduce you to is the word radian. Now, think about 360 degrees is fairly arbitrary. Why is the circle broken up into 360 degrees? Some say the ancient Greeks thought that was how many days there were in a year. Well, they were pretty close. Others say it was very divisible because you can divide it by a whole lot of numbers evenly, but nobody really knows. Now, a radian is not just an arbitrary number. The definition of a radian, well, let's do the picture first. So here's our circle, and this along here is the radius. And if I take that and put it along the circle and curve it, that distance that it just went, that angle is considered 1 radian. Okay, now if I did that again, I take the radius and I go along the circle a little bit more, I'm going to end up right here. If I do it again, I'm going to end up down here. And then there's this little chunk left over. So I have 1, 2, 3 radians plus this little chunk. I'm wondering if you're thinking what I'm thinking. That little chunk is about 0.14 of a radian. And notice altogether there's 3.14 radians in 180 degrees. Now that should be very familiar. That's where the number pi comes from. I don't know if anybody really realizes where it comes from. It's how many of the radius can fit around the top half of the circle. That's where pi comes from. And the circumference, remember, is 2 pi. So if I multiply this by 2, I get 6.28. So there are 6.2 radians in the full circle, or 360 degrees. Okay, so you're going to have to start using the idea of pi and 2 pi radians rather than degrees. And we're also going to break it down into other angles too. So the definition of a radian, let's write that down. It's the measure of the angle formed when its arc is equal to the radius. Okay, so the arc being this part right here. All right, now arc length. Speaking of arc, we have arc length. There were ways that you found it in geometry. We have a little bit different formula. Arc length, we're going to use the letter S. I don't know who came up with that. It's not an A for arc, but it's just S for the arc length. And that angle that is made is taking the arc length and dividing it by the radius. Or you can rearrange it and bring the r to this side, and I get S equals theta r. I like to call that my soar formula. Think of birds in flight. They have little arcs, and they are soaring through the air. So arc length is the angle times the radius. That's how you're going to find it. Let's do a problem with arc length real quick here. So if I use my SOAR formula, I can say, now the thing about formulas is you have to use radians when using formulas. Okay, degrees don't work in formulas. You can multiply degrees by numbers, but if it's an actual formula, you may not use degrees. They don't work. They're not regular numbers. Radians are regular numbers. So if I take 2 pi as my arc length, I'm going to, we said before that was equal to 360 degrees. So that means 1 pi, or just pi, is equal to 180 degrees. Pi over 2, cut that in half, is 90 degrees. And pi over 4 is equal to 45 degrees. Okay. We're going to just talk about converting. So if I want to convert from degrees to radians, if you look at this, to go from degrees to radians, now the simplest one is probably this one to work with because it's got the fewest amount of symbols and no fractions in it. To go from 180 back to pi, I would have to multiply by pi over 180. So if I take 180, multiply by pi over 180, these cancel and I'm left with just pi. So that's your conversion factor. You need to multiply by pi over 180. Okay, if I want to convert from radians back to degrees, we're just going to do the reciprocal of that. You're going to multiply by 180 over pi. Now the way I remember this is if I want radians to be my final answer, I don't want degrees, so degrees will go on the bottom and cancel out. If I want degrees, then degrees goes on the top, 180 degrees goes on the top, and the other will cancel out. Let's do a couple problems here. Let's say I have 30 degrees. I want to convert that to radians. So I'm going to take 30 and multiply it by pi over 180. Now the 30 and the 180 will cancel. This will be 6, so the answer is pi over 6. Now let's figure out what that really means. 30 degrees is 1/6 of 180 degrees. Now 180 degrees we said was pi, 3.14. So 1/6 of pi is pi over 6. So we're going to write it that way. We're not going to write 1/6 of pi. How about converting -5 pi over 3 back into degrees? So we're going to multiply that by 180 degrees over pi. Pi's will cancel out. This 3 cancels with this, and we get 60. And 5 times 60 is 300, and then this negative sign makes it -300 degrees. Okay, so that would be a negative angle. You'd go down for that one. All right, let's talk about how do we draw these angles. All right, if I have my circle, and we already said 180 degrees was pi, and 360 was 2 pi all the way around. If I want 1/4 pi, or pi over 4, I have to think of the top half only. Okay, a lot of kids want to think 1/4 of the circle. No, it's 1/4 of pi, which is the top half. So if I broke this into 4 equal pieces, right here would be 1/4 of pi. Now you're probably used to it being 45 degrees, which is fine. You're going to have to convert back and forth. Okay, so each section. So what would this one be over here? If this is 1/4, you keep counting. Here's 2/4. This one's 3/4 pi. That would make this one down here 4/4 of pi, which reduces to just plain old pi. You could keep going. Here's 5/4, 6/4, 7/4. This would be 8/4. So depending on what your denominator is how you're going to divide this circle up. Let's do another one. Let's do, how about, where is 4 pi over 3? Well, I need to cut this into thirds now. So the top half only, I want to cut into thirds. So about here, here, and here. So this is 1/3, 2/3, 3/3 pi. If I go another third, that's going to be 4/3 pi. Here's another third, is 5. Here's another third. This would be 6/3, which is the same as 2 pi. Okay. I wrote this as it should be thirds over here. Sorry about that. Don't want to mess you up. So just no matter what you're counting by, the denominator determines it, and you have to think of breaking the top half into that amount. All right, the next thing I want to talk about is the word coterminal. All right, coterminal. Now, like co-captains on a baseball team, is there's two people that are the captains. They're two different people, but they do the same job. All right, and terminal means where it ends. So this means same end, different angle. Okay, so for instance, here's our 1/4 pi or pi over 4. If I go around the circle all the way around and go back to that same spot, that's a very big angle. That's more than 360 degrees. In fact, it's pi over 4 or 45 degrees more than 360. So if I go all the way around, that's 2 pi, plus the pi over 4 I just did, or I had to begin with, it is 9 pi over 4. Think of 2 pi as 8/4 and add those together. Okay, so one way to do this is just to add 2 pi. Okay, to find a coterminal angle, you add 2 pi, or you can subtract 2 pi if you want to get a negative. It depends what the directions are asking you. Do they want it between, a positive number, between 0 and 720, or 0 and 4 pi, or whatever the directions are asking you to do. Now, if I were in degrees, you would add or subtract 360 instead of 2 pi. So same process, but that's all coterminal is. There's millions of coterminal angles with pi over 4. Just read the directions as to which one they want. All right, before I said we're going to do an arc length problem with a SOAR, I decided to wait till the end. Okay, the main thing is you have to make sure you're in radians. And let's say I have a circle with a radius equal to 10 inches, and we have an angle, a central angle, is 120 degrees. So if I drew a picture of that, 120 degrees starting from here would be about there. That would be our angle theta. So we want to find this arc length S. This is 10, this is 120. So we just plug it into our formula, and I get S equals 120 times 10. Now, this is in degrees. I can't have that. So I need to convert by multiplying by pi over 180. So that turns it into radians. You cancel stuff out or you just multiply it through, you should get about 20.94. And because this was in inches, our arc length is also going to be in inches. Okay. All right, that is it. This video is 19 minutes long. Usually I don't go that long, so I apologize, but it was the first video, so I wanted to make sure I went slowly. Okay, remember, take notes, and if you love Trig, Trig will love you back. All right, I'll talk to you in class. Bye-bye.